Okay, here in example 4, we can see we're going to be using a lot of that one-to-one property. So if you look at A, we see that we have log base 5 of y equals log base 5 of 16. Again, I've got log base 5 equal to log base 5. We can cancel them, so we know that y has to equal 16. On B, we have the same idea. We've got log equals log, same basis. There is something being added or subtracted this time, but it's all together inside. It's not like I've got a separate minus 7 thrown on at the end or something there. If I had, then that's a whole different story, and we'll talk about that later. But right now, I've just got log of something equals log of something, so you can throw out your logs. And you have 4 minus 3x, it has to be equal to x plus 2. We'll just solve for x, so I'm going to move my 2 over, and I'm going to move my 3x over. So when I do this, I end up with 2 equals 4x, divide by the 4, and we get x equals 1/2. Now, I want to say that yes, that's my answer, but remember, we said in one of the previous examples, you cannot take log of 0 or a negative number. So I need to take this 1/2 and I need to plug it into both of the equations that I'm taking the log of to make sure that it works. So I'm going to check this 4x plus 3 first. So I'm going to plug in the 1/2. So I got 4 times 1/2. I'm sorry, I wrote that wrong. I'm going to plug it into the 4 minus 3x. And let's see, so I get 4 minus 3 times 1/2. So, which ends up giving me 2.5. 2.5 is not negative, nor is it 0, so it's okay. Then I've also got to check the x plus 2. So when I plug it in for x plus 2, I get 1/2 plus 2, which is also 2.5, so it works there as well. So then I can safely say that yes, 1/2 is my solution. Then I go to work C. Same idea. We've got log base 3 equal to log base 3. So we know that x squared plus 4 has to equal 29. Well, there's several ways you can do this. You could set it equal to 0 and factor using difference of squares, or we can just, since there's no x term, it's just x squared, we can get the x squared by itself and then take the square root to get rid of it. So doing that, I get x squared equals 25, take the square root, but you have to be careful on this, because when you take the square root of 25, remember, you get a positive and a negative 5. Well, knowing this again, you have to check both of them. So first I'm going to start with checking my positive 5. So the only thing I need to plug it into is x squared plus 4, because the other one is just a 29. So when I do the x squared plus 4 and I plug in the positive 5, I get 5 squared plus 4, which is 25 plus 4, which is 29. So positive 5 works. That's definitely my solution. So then I'm going to plug in the negative 5. So I get a negative 5 squared plus 4. Negative 5 squared is 25 plus 4, which is also 29. So the positive and the negative 5 work. So when we say that, that you can't take the log of a negative number, it doesn't mean that x can't be negative or that x cannot be 0. What that means is when I plug it into whatever I'm taking the log of, and in this case that was the x squared plus 4, that cannot equal 0 or a negative number. X can be positive or x can be negative. It's just as long as when I plug it in, I don't get 0 or a negative number. Hope this helped.